slides are visible?
Yes, your slides are visible.
And I'm audible?
Yes, yes.
Yeah, yes. Yeah. I think it is suddenly rescheduled. Okay, I have planned my talk for 45 minutes, but I mean, it is a kind of a lunchtime, and I don't want to put many of the viewers into what do you call a kind of a late lunch. I'll try to what do you call finish it as fast as possible. Though I have planned it, my talk for 45 minutes, I'll try to restrict myself to around 30-35 minutes. The First of all, I mean, Professor Naveen Sheth, Professor Chaitanya Joshi, Dr. Prashant, and my what do you call colleagues, both past and present, from the DSIR family, Dr. Alok, Dr. Purushottam, Dr. Pankaj, and Dr. Mitab, and all the invitees for this outreach programs and faculties of Gujarat Technological University and the students. I failed to see the participation of the students actively in this outreach program. I don't know for what reasons, because these kind of an outreach programs are largely meant, even Dr. Purushottam lecture, it is largely meant for students who wants to become startups or students who wants to become researchers, students who wants to become entrepreneurs. These outreach programs basically helps them to take the guided way of taking it further. And it has all been done as a part of India International Science Festival 2020. And I'm sure that the introductory remarks of my previous speakers, both by Professor Joshi and by Professor Sheth, very clearly mentioned about the role of science and its implications in the lives of the people, and how it is basically intricately linked between what science is being done in the four walls of the labs, and how it basically influences on the larger forte of the mankind. And this is through this festival we reinvigorate that concept, and hopefully we see India where, I mean, science is also a part of what do you call culture and system in place, so that these festivals are intricately linked with the human beings. I mean, that is the wish that I wish to pursue in the years or decades to come. With this introduction, I was asking Amit for what kind of a topic that I should give and what kind of an audience would be there, because that's more important. Depending on the audience, depending on the what do you call expectations of the audience, the way that we basically connect to the people will be better. And he was telling me it's more of a large number of students and faculties of GTU, and maybe from the entire Gujarat on the whole. So I have configured my talk, and he was telling me to give some information about our institute, the only CSIR institute in the state of Gujarat, Central Salt and Marine Chemicals Research Institute. So he said, I mean, this could be a fort of your lecture presentation is. So I was basically thinking, I mean, I don't want to give only the institute talk. I wanted to give a kind of a concept around the institute. So I was critically analyzing the institute's recent performances, and when we were seeing it, there are certain examples which very clearly came out. The one of the major agenda of importance of partnerships. So I just thought, I mean, I'll give you through stories, because it's very easy to reach rather than talking about abstract terms, which is good for a reasonably well-read audience or what do you call versed audience, where the audience is not that well-versed or what do you call read. The stories basically reaches and impact better, and that's the way by which I thought of taking it further. I'll be telling about 3 stories which are the recent examples of this institute, and wanted to emphasize how the partnerships plays a very critical role in science building. And I also reiterate what Professor Sheth and Professor Joshi mentioned and Professor Dr. Prakash mentioned in his opening remarks. This Science India Fest is something which is meant for largely for the science enthusiasts, especially for the students, teachers, faculties, entrepreneurs, startups, all those kind of people who are believing science is which is a kind of an undoubted concept, at least to my mind, about how science is influencing it. So I request all the participants, please convey this message to your friends, neighbors, peers, all of them, to register this event at www.scienceindiafest.org. And where, I mean, there are, as Dr. Prashant said, there are 41 events, and you can participate in any one of the events, which, I mean, he has talked about in 9 verticals. You can, participate in any one of the events to make it a kind of a successful. We embrace, I mean, in fact, 100,000 people, because of the net issues, I would expect virtual would require a kind of a larger participation than physical. If it is conducted in a particular city, all of us cannot basically go to that city and then do it. But if it is conducted virtual, one can sit at the comfortable of home or a office or a park where you can basically participate in this science festival. So with this brief introduction and request for participation in this active participation in this science festival, let me just give a kind of I structured my talk with a kind of 4 issues. One is about briefly introducing about what the institute is all about, because it is important. There are many students, many faculties coming from different parts of the world. In fact, I mean, we shared some of these links to some of the other colleagues also. I just give a kind of a brief introduction about the institute, and then I'll take you through those 3 stories, which basically emphasize on the partnerships. And as I said, I mean, CSIR is a Council of Scientific and Industrial Research, an autonomous body under the Ministry of Science and Technology, under the Department of Scientific and Industrial Research, where we have around 38 national labs spread across the country. And the Central Salt and Marine Chemical Research Institute is the only institute in the state of Bhavnagar which exclusively work on different kinds of chemistries, which are niche for this nation. And we do have a kind of a field station, which is called as Microalgae Research Station. It is located in the southern coast of India, located close to Rameshwaram, a place called Mandapam, where, I mean, a unique activity is being carried out, which is kind of a niche for this country on the whole. And to give a kind of an history, this was inaugurated by the first Prime Minister of this country in 1954. It's roughly, I mean, close to around 70 years. And this institute is then started for the Atmanirbhar Tha, because when we partitioned ourselves with Pakistan, we were not having enough salt to feed our Indian population. And this institute was born with a kind of a self-reliance of salt availability and salt productivity in this country. And with this institute born, and with the R&D that is developed in the formative years of this institute, India becomes self-reliant in 2 decades. And I'm very happy to say at this point of time, India is the 3rd largest producer of salt next to China and United States. And we have an ambition of becoming a kind of a 2nd largest producing country in the next few years to come. And this is the kind of transformation that we have seen, where a country which was not enough to produce to feed the Indian population, our own fellow countrymen, has now become a kind of a largest salt producing nation in the world, and feeding several other countries through exports. And if I were to talk about what are the current research that we are doing, and if you really see, I mean, these are the 2 broad areas that we work. We work on chemical research and biological research. And largely under the chemistry foot, our core domain is on the salt and marine chemicals. We also work on algology based chemicals, that is both marine microalgae and marine macroalgae. Everything will be around sea. And then we also have a kind of a very niche area of catalysis driven chemicals, which involves green chemistry principles. And we also work on polymers and membrane based chemicals. We work on inorganic materials. This is the only laboratory in the country where inorganic chemistry is practiced to a very large extent. Salt, marine chemicals, inorganic materials, all these are all kind of a fort for this particular institute, and also a kind of inorganic and organometallic chemicals for different kinds of sensing and diagnostics applications. And as far as the biological research are concerned, we work on, as I said, on marine microalgae and macroalgae. We also work on halotolerant plants, and we use high-end biology and biotechnology for understanding the how these plants behave and how the behavior of the plants can be basically put into a kind of a valorization. As Dr. Purushottam said, the research needs to be translated into a kind of a value, and the value can be in terms of a revenue, or the value can be in terms of a benefit to the mankind. And these are some of the ways, like marine microbes, bioactives, or marine ecology, or something which we are basically working intensely for different objectives in the foot of industry and societal needs. And we have roughly around 80 scientists and roughly around 200 students were working on these domains, and which is well equipped with the different infrastructural facilities. The most important point I wanted to emphasize it is this institute is a more of a technology-centric organization, where, I mean, whatever we do, we develop a kind of a technologies around that, our research. And that technology either is put into a kind of a benefit of the society, in the welfare of the society directly, or in terms of supporting the industry needs in terms of higher business opportunities or higher revenue generation, largely in the fort of certain marine chemicals, inorganic and organic chemicals, polymers and membranes, waste to wealth, and in other greener technologies. Then the most important point that I wanted to say about here is all these technologies are all IP protected, which clearly says that the previous speaker very clearly mentioned about how IP should be correlated with the prosperity of the nations. Okay, there are examples he went through about how IP's prosperities, economy, and growth, innovation index, all these things are all interlinked parameters, and the technologies that we develop are all always augmented by a kind of patents. And our organization, our institute, is one of the front runners in the nation level on the number of IPs generated on a per capita scientist basis. And this is also backed by very strong research publications. So we work on a kind of a technology which is backed by a IP, which is further understood very critically for with intense research, which basically closes the loop of a cycle for developing a kind of a better technologies. And in fact, I mean, the impact which is defined by certain parameters, the institute ranks probably one of the top institutions in the country on the whole. And we do a lot of human resource at different levels for undergraduates in terms of internships programs, for masters in terms of projects or internship programs, and for doctoral and postdoctoral studies for taking up a kind of a high-end research which is of relevance and meaning to the society and industry. And we also undertake several kinds of skilling programs which essentially makes this startups, entrepreneurs to skill themselves to equip themselves before they enter into a kind of area. and we do several training programs and outreach also for the different kinds of an outreach, right from the schools to kind of companies. We do several kinds of an outreach programs, and today that we are talking about is another kind of an outreach where we are talking about how the India International Science Festival connects all of us through this outreach program to make some sort of a sense and some sort of a belonging in the forte of science and technology. And these are the larger domain that we broad domain that we do. We are a knowledge intense organization coupled with a kind of an intellectual strengths, and which provides different kinds of services, but in partnership. So my today's lecture would be on the partnership. I would be talking about it. So I don't want to tell about partnership. Here, I mean, I'm talking about partnership in terms of a science. The stories that I'm going to talk about will essentially tells you how the partnership makes the synergy, where we wanted to advocate a philosophy. Synergy means 1 + 1 should always be greater than 2. Okay, it's not mathematical. It is something which is beyond mathematics. So this is the story that I just wanted to tell, which is basically on a public-private public partnership. What is this? I'll run you through the stories, and I'm sure that because of the diverse audience, don't get into two criticalities. You have to understand the message around it. Fine chemicals are a fabric of all our necessities. Whether you touch your toothpaste, whether you touch your soaps, whether you touch your perfumes, whether you touch your deos, okay, fine chemicals plays a very critical, or whether you touch your agrochemicals, whether you touch your pharmaceuticals, all these things are all largely a kind of a fine chemicals. And most of the chemicals, 90% of the chemicals that are produced in this world are somewhere or other are driven by catalysts. Catalyst is the one which basically drives the reaction in a kind of a reactant R to a product P in a faster time without itself basically being consumed in the reaction. It only accelerates this rate at which the process of R to P is happening. And fine chemicals are not exceptions. There are several kinds of fine chemicals. Almost, I would say here, more than 99% of the fine chemicals which are produced in this country or produced in the whole world, or somewhere or other, the catalysts play a role of their making. And the catalysts, if you really see, there are several catalysts are used. Broadly, they can be classified as a homogeneous catalyst and heterogeneous catalyst. And there are several kinds of reactions are involved. For a chemistry audience, they will be knowing about the terminology like hydrogenation, oxidation, isomerization, esterification. For a non-chemistry audience, these are the words that must have been learned in the school levels. Don't get into those memories, but what you have to see is there are some chemical reactions which takes R into P, and one of that chemical reaction is hydroformylation reaction, which is very, very important for making different kinds of oxo products, which we are everyday using it. The only beauty of chemistry is we use chemistry right from the whenever we wake up till our go to bed. Chemistry is inflicting on the fabric of our lives. And several kinds of chemicals using hydroformylation reaction, which is a kind of a reaction where two molecules, carbon monoxide and hydrogen, is added to a olefin to get a kind of a different aldehydes and different other kind of an oxo compounds. And this is a very interesting reaction where, I mean, a kind of an homologous series. If you're starting with a kind of a carbon number N, it goes into a kind of an N+1 kind of a compound with a kind of a functionality built into it. So there are two important things that are happening. One is the carbon number is basically increased. At the same time, I mean, you also introduce a functionality, because the functionality offers chemistries to be taken up, and that chemistry leads to the kind of a different products which we use on our everyday lives. The beauty, I mean, these are different uses of the oxo compounds that I've talked about, aldehydes. And the beauty is the chemistry and the catalysis is always have a kind of an evolution. Okay, we start with a kind of a and we are not happy, I mean, with the A, and then goes to B and goes to C, and that's how the research basically progresses. And hydroformylation is no exception. And there are certain what you call catalysts were tried as a kind of a first generation catalyst, and which are based on cobalt. Okay, and the activity, as I said, I mean the reactivity, how many molecules are basically converted on a given time on a given what you call set of what you call active sites. This is something which is a kind of a driving force for the discovery of a newer catalyst, and we enter into a kind of a third generation of catalyst. I believe my presentation is. Somebody is basically what you call sharing their presentation. I request, I mean, not to share while somebody is presenting it. Okay. So the next when we are discussing about these generations of catalysts. Why do we need to go for a generation of catalyst? Because we wanted to get it in a kind of a faster time with a kind of a lesser amount of what you call sites, with a kind of a very high activity, which means if I'm taking 100 molecules of A, it should basically get converted to 100 molecules of B. But while forming B, which is the active what you call entity, you may end up in a kind of a molecule C, D, E, F and all. We don't want those C, D, E, F to be there, and that we call it as a kind of a parameter called selectivity, and we wanted B to be formed exclusively. And these are the critical things for any kind of a catalyzed reactions. And the best part of it is this institute was also working on this kind of a hydroformylation reaction, worked on different sets of a catalyst, and worked with the different kinds of olefinic molecules and different functional molecules in creating a kind of an different aldehydes. And here, I mean, if you really see a CHO, which is a kind of an aldehyde functionality, which is attached at the terminal end, and one it is attached at the branched end, and you really need a kind of the terminal end aldehydes to be more produced for certain applications. It gives you a kind of a larger opportunity for making more diverse molecules. How do you selectively get that particular aldehyde without having any other kind of other compounds or even the isoaldehydes to be produced? It's a great challenge that everybody is working on it. And this is exactly the challenge where one of the what do you call companies which everyone knows, Bharat Petroleum, has been working on it, and they were interested in a kind of a particular hydroformylation reaction for making a kind of a diverse kind of a molecules. And this is, I mean, again, a kind of a multi-billion-dollar industry. This hydroformylation reaction alone, if I were to basically talk about in terms of our revenue, and there are certain challenges. Okay, challenges is when we are talking about Atmanirbhar Bharat, most of these catalysts are generally imported, in the sense that we may be having a kind of a technological expertise, but the critical components which are needed for conversions are largely imported. And Bharat Petroleum, they said, why not we basically indigenously design this catalyst? And they had their own what do you call R&D divisions, which is working on this particular forte. And they said, let's not work alone in isolation, because the transformation of isolation working in silos is not going to be a kind of what do you call a logical or a time-bound way of doing things. So let's work with a kind of an organization which are having a kind of an expertise on this. And this way they have collaborated with our institute. They partnered with us. They said, we wanted to design and develop this catalyst, which could basically make a kind of a self-reliance in the years to come. They had a kind of a time window of 5 years, and then they said within 5 years, we wanted to basically move away from what do you call imported catalyst to a kind of an Atmanirbhar catalyst. And they told us what are the challenges we need to overcome and what kind of a parameters that we need to what do you call achieve, which is of this thing. And this slide, I don't want to get into the details. This slide essentially speaks only one message, that this what do you call chemistry is important. The products that are going to be used is going to be made, is going to basically influence the what do you call health and well-being of our Indian population and beyond. And that's the whole message of that slide. And we entered into this kind of reactions, and we started working on this reaction for the last 1.5 years to 1.5 years. The objectives were very clear. We have to basically compete with the imported catalyst. And we wanted to have a kind of a work to have a kind of a realization. And this, the engineering expertise of the Bharat Petroleum is pretty high. The chemistry expertise of the institute is pretty good. And they said, let's combine the engineering expertise and the chemistry expertise together in a collaborative mode, design and develop the catalyst. The testing would be done at both the ends, and then scale it up, and a translation would be done, and a kind of bigger realization before we actually replace the catalyst which is commercially working by the catalysts that are indigenously developed. And that's the beauty. And the outcome of the collaboration is, the beauty is the institute has identified a particular set of a catalyst which is having a kind of a very high activity, and whatever the lab scale demonstration that needs to be done has been done. Now the scale up work will be done at Bharat Petroleum, which would basically put the engineering expertise to put a kind of a semi-continuous commercial semi-pilot scale. And once they get a kind of in the next 1.5 years, if they get into a kind of these catalysts which are developed in the labs are put into a kind of a semi-commercial validation, this would be basically replaced in the next 3 years down the line. And the time frame that we have been given is 3 years down the line. And this is a classic example where, I mean, the chemistry part of the organization is working along with the engineering expertise of another organization to make a kind of a larger dream of self-reliance in a domain which is a kind of having a kind of both revenue as well as the well-being of the nation on the whole. And of course, all these things, these joint research are always a kind of where, I mean, the IPs and knowledge capitals are always shared. And the second example, that is basically, the first example is a public-public partnership, where ours is a public-funded organization, and BPCL is also kind of a public sector organization. That is an example where how the partnership has culminating into a kind of a Atmanirbhar Reliance. The second example that I wanted to get through is about public-private partnership. And this particular public-private partnership, I'm going to run through a kind of a story, which is on a kind of a agro-derived chemistry with a kind of an engineering expertise. So there is a kind of an agriculture, there's a kind of a chemistry, and there's a kind of an engineering. All three segments are basically what you call camouflaged on this example. And I mean, if you really, I mean, go to any kind of sugarcane producers, and then the sugar mills are basically processing the sugar canes, and they produce sugars, and they end up in a kind of a molasses which goes into the distilleries, and these distilleries are largely producing alcohols for different use. The most important thing is when you are producing alcohol, you end up in a kind of an effluent which is called a spent fortune. It's a kind of a menace. Okay, when you end up in when we are advocating about green chemistry principles, we wanted to have a kind of a no discharge or a kind of a zero waste processes. These are the buzzwords in the chemistries and in the economy, or in the way the industries would like to work with. And this is a classic example. And the beauty of it is the one which is a notorious and obnoxious thing, which is actually the spent force. And what do we do with that kind of a spent force to make it a kind of a valuable proposition at this point of time? And there has been a kind of a tremendous amount of concerns which are expressed about the pollution related effects of these spent force, which clearly tells that I mean, there is a kind of a need to do something to do with that to make it a kind of a green and eco-friendly process. There are some at this point of time there are a couple of options are available to treat that, and they are more of a kind of a getting rid of the problem, not to basically make a kind of a solution out of the problem. And this is I mean, a kind of a growth profile. I mean, India is probably, I mean, it is the second largest producing country in the world, sugarcane producing country in the world, and this is going to continue. Okay, considering the kind of vision that we wanted to basically blend ethanol into our fuels. where I mean the percentages is on the continuous rise. Ethanol production in this country and sugarcane cultivation is going to go up in the years and decades to come. So the molasses are going to come and the spent phosphorus is going to be generated. How do we basically deal with it? Is something which is very important. The spent phosphorus management, makes a kind of a key. And if you really see, these are the protocols that are basically adopted. I don't want to get into the technical details of it. What is the message that I wanted to convey in this slide is this particular work is kind of a work where we are not basically wanted to get rid of the problem. We wanted to basically engage on the problem and then see whether what kind of a solution that can be basically given on this problem. And that's the beauty that we went into it. And this is the India sugarcane map. And this is the kind of a numbers that you can see that we produce kind of a roughly around 30 to 35 billion liters of spent phosphorus. That's not a small number. That's really not a small number. And this one, handling this kind of a large numbers requires a kind of a technology which are scalable, sustainable, deployable, and at the same time, it is more cost effective as well. And these are the advantages of this would make a kind of a tremendous impact in terms of agriculture, in terms of a soil health, in terms of water, in terms of groundwater, safety, or in terms of the ecosystems, like for example, the riverine ecosystems. So it makes a kind of a tremendous amount of contribution in different sectors. One of the beauty of this, spent phosphorus is it has some amount of potassium in it. And that amount of potassium is very similar to the amount of potassium that is present in sea bittern. What is sea bittern? Sea bittern is when you basically cultivate salt, the residual matter that is basically coming out is a sea bittern. And sea bittern is a rich source of potassium, and that potassium can be basically extracted out for potassium resources. And the beauty is the percentage of potassium that is present in the sea bittern and this one is almost similar. That's number one. And number two, this institute has developed technologies for extracting potassium from sea bittern and from several other potassic sources. So there's a kind of a competency that this institute had got, and that is so we worked on the spent phosphorus also as a kind of one of the resources of creating a kind of a potassium and see whether we can make a potassium in this country. Why do we need potassium? We need potassium because everyone knows that potassic fertilizers are extremely important for several crops in this nation. And in fact, I don't think any agricultural field in this country is not using potassium. So potassium is kind of an omnipresent fertilizer for the entire Indian agricultural backbone. The worst news, which is a kind of unfortunate news, I would say, is unfortunately the entire potassium that is used by our Indian farmers at this point of time is completely imported. Not even a gram of potassium is produced in this country. And this is something which is a very, very, though efforts have been done, and unfortunately still it is not percolated the potassium production in a kind of a scale that would make at least even 5% or 10% of the Indian farmers are using indigenous potassium. So this is a kind of a pain point that we had. It is needed. Okay, it is present. And it is completely a kind of an imported, okay, where Atmanirbharta is at this point of time is virtually close to nil. And what do we do on this? So we said, let's develop a kind of a process to extract out the potassium from this. And the beauty of it is we developed this particular process in a kind of a flask in our labs. And there's a company called as Chem Process Systems, which is located in Ahmedabad. They were working on this problem and they were not finding a good way of extracting the potassium out. They were literally, before they met us in 2016 over a cup of tea, they were not knowing that this institute has been addressing the work of spent phosphorus management. They were working on the spent phosphorus management. And then they were also knowing about it. There is a potassium present in it, but they could not, have a kind of a solution of extracting it out of the potassium. So when we were telling about it, that we were working on this and we were basically extracting out the potassium in it. So they said, why don't we join our hands and then take it further on this? The best part of it is they said, okay, I mean, we will basically what you call put up a kind of a pilot plant for the technology which is just demonstrated in a 1 liter flask in the lab, just demonstrated in 1 liter flask. Okay, they said, I mean, why don't we basically take it up to a kind of a 2,500 liter pilot plant and then see whether it is what do you call translatable, what kind of what do you call things would challenges that we would be getting it when we are actually working with a kind of a spent force. So we tied up with, I mean, both these organizations tied up with a distillery, and then, I mean, the distillery spent force basically was taken up, and then the technology was adopted. The beauty of it is when the technology was adopted, several newer what do you call concepts emerged, and then they said, what do we do with the kind of an organics that is present in the spent force? And how do we basically separate it? In what way we have to basically separate them? What kind of a chemistry that needs to be done? And how the biology has to be separated from the chemistry? What kind of what would be the kind of a benefits from it in the overall what do you call scenario? And all these things were basically discussed while what do you call discussed and worked upon while pilot plant facility were checked up. And then, I mean, we said, I mean, let's collaborate with still better more organization like the organics that are coming out. Can we basically use them in place of molasses as a kind of a cattle feed supplement? Okay, where I mean, it can be used as a kind of a binder for cattle feed. So that requires a kind of a validation from other institutions like what do you call agrocentric institutions, which are responsible for what do you call milk like NDRA or Sabar Dairy or NDDB kind of an organization, a dairy related organization. And that's how we basically what do you call collaborated with all these institutions to come up with a kind of what do you call model which is making a kind of income for the distilleries also very high, and also for the and also all the what do you call stakeholders, the farmers, the distilleries, the cooperatives, and of course the government. Everybody was a kind of a business win-win kind of a model, and these are the certificates which basically told that I mean the organics that are basically what do you call we call it as spent for vinasse. Okay, desalted vinasse, depotash vinasse, and this particular was used in a kind of this thing and proved that it is equally doing a kind of a very good health on the cows and buffaloes, and at the same time, I mean, the milk product was also having a kind of a good quality, and this could be a kind of a very good substitute for the molasses. So the technology is basically now creating a kind of a solution where potassium can be basically separated out, and that could go into a kind of an agricultural field for the benefit of the farmers, and the organics can go into a kind of a dairy segment. And the most important thing is sugarcane being distilleries being a kind of a water intensive industry. The water that is basically coming out from this what do you call separated constituents is now pulled back into a kind of what do you call the loop itself, which is basically making a kind of a complete circular economy in terms of its what do you call this thing, and the entire what do you call stakeholders have what do you call witness about this technology, and this technology is now getting validated at a kind of a highest offices of this country. And I'm sure that very soon that this technology would be adopted by several tens of distilleries. There are around 300 distilleries. Our dream is in the next 3 years, at least 25 to 30 distilleries of this country should be adopting this technology. And in 2019, there were 2 technologies Honorable Prime Minister has what do you call given a kind of a press message, which is a kind of a appreciative message for 2 technologies developed in this nation. And this is one of the technologies which won even the technology award from the hands of the Honorable President of this country as well. And the best part of it is, I don't want to, because of the time, I don't want to get into it. And the best part of it is a commercial plant is running and operational in Maharashtra, which is operating at a 60,000 liters per day kind of a capacity. Just imagine from a 1 liter flask to a 2.5 KL in a pilot. Now we are basically talking about a 60 KLPD kind of a scale. And we wanted at least several thousand KLPDs are adopting these technologies in the years to come. And this is a classic example because the private equity guy who came and then invested money on the technology, just believing what we have done it in the lab for a couple of hours, and then invested money, and then now he was basically taking it into a kind of several stakeholders and several line ministries for making this technology applicable for the distilleries of this nation. This would not have been possible if either we worked in a kind of a silos or they worked in a kind of a silos, whether they were working in a kind of a separation of potassium or we were working in a kind of a complete integration of engineering right from a 1 liter flask to 60,000 liters per day. I mean, this journey would not have been possible had it not been a kind of a public-private partnership is in place. And I clearly say this is a classic example where, I mean, as Dr. Purushottam said, industry needs to invest on the R&D with the interact with the R&D institution. And this is one of the classic example within the span of 4 years down the line. It doesn't take some decades. It took only 4 years from 2016 over a cup of chai, and then the commercial plant was operational in 2019 February. Within 3 years, the commercial plant is up and running. And that's the kind of a spirit with which public-private partnership can enable the science discoveries into a kind of a application which would benefit a large section of stakeholders. The last story that I wanted to basically talk about is it's a public-private partnership. So what is this story is all about? This story is, I mean, as I introduced you in the initially, I mean, I'm just 5 minutes more. Okay, I'm running late. Okay, so this is about marine macroalgae, which I discussed about you in my initial remarks. These are commonly called as seaweeds, which are basically grows in sea. And the beauty of it is that these seaweeds doesn't require any kind of a fertilizer. It takes nutrients from the sea and it grows, and its growth rate is phenomenal compared to even land-based plants. And it is a kind of a centric activity where, I mean, women empowerment is very, very high. And this particular seaweeds, when you when you crush these seaweeds, you end up in a kind of a sap, a liquid, which is called as, we call it as a sap. And this sap is having a kind of a tremendous amount of micronutrients and plant growth promoters present in them, and that is basically helpful for the plant growth. So by adding the fertilizer, along with the fertilizer, if you add these biostimulants also, okay, the seaweed based sap, the productivity of the crops increases from 12% to 37% of the yield per hectare of the crop. Any kind of a crop, depending on the nature of the crop, depending on the nature of the soil, the productivity value will change. And that is really a kind of an additional income for the farmers. And the best part of it is one of the entrepreneurs who is no longer now entrepreneur, who is now basically going to cross a kind of a top 100 crore club, which what Purushottam said, if one guy crosses any one of the last preceding 10 years, 100 crore club is basically goes up. He is no longer considered as a kind of a startup. And this company will be now crossing a 100 crore club. And they tied up with a kind of another company called as IFCO. And they are marketing this product, which is being used by several hundreds of farmers in this country. And this is a kind of a field trial where the collaboration came in, where the public collaboration came in. See, I mean, this particular sap that is basically developed from the seaweed needs to be validated on the field. How do we basically connect to the fields? So we have to work with a kind of agricultural institutions and universities. This institute worked along with agricultural institutions and universities. Over 41 agricultural institutes and universities in the country, across 20 different states. Okay, on more than around 35 different of crops, and where, I mean, the crop acreage was not less than an acre, where the testing and validation was done. And that's the kind of a scale of experiments where, I mean, an individual institution cannot do. It requires a tremendous amount of collaboration and cooperation. And that's the way, I mean, after 3 years of work with several thousand hours, man days of efforts of several, agricultural scientists and farmers, the results were validated, and it was proven that this particular sap, which is developed from the seaweeds, has a kind of a capability to increase the productivity of the crops significantly. And that is the whole important message I wanted to convey across. The most important point is, how does it in fact influence. I said, I mean, the first example was on revenue generation. It's a multi-billion-dollar industry, the hydroformylation reaction. And this is basically converting into a kind of a social economy. This thing. You just imagine several thousands of fishermen are involved in the cultivation of the seaweeds. They are getting empowered. They're getting a kind of an additional income by the cultivation of these seaweeds. So when they get engaged in the cultivation of seaweeds, and the industries are going to basically be the buyer of these seaweeds, and they produce for what you call sap out of it, and this sap is going to be given to the agricultural farmers who are going to basically use it, and then through that, I mean, you get a kind of an additional revenue for the farmers. In fact, I mean, there is a kind of an estimate, although we don't have a kind of what do you call it, direct evidence, an estimate that last 3-4 years of use of these seaweed biostimulants produced in this used in this country has given a kind of an additional revenue of over couple of thousand crores of additional farmers' income. And that's the kind of an impact that we can basically draw into, a kind of a women empowerment to the agriculture through the science and technology intervention that would only happen through kind of a collaboration. So that's the beauty of it. And we did not, stop there. We extended even to the, animal segment, both for the lactating cows or calves or broiler chicken or any kind of poultry. Okay, I mean, where the addition of the seaweeds, and some of you might have seen this newspaper cutting got published in Times of India, I think last month, where, I mean, this again was a kind of a collaboration from three, institutions, namely IVRI, Indian Veterinary Research Institution, Central Avian Research Institute, National Dairy Research Institute, along with Dr. Alok Dhawan's lab of Indian Institute of Toxicological Research. All these institutes worked in kind of a collaboration, and then we demonstrated the use of biostimulants indeed helped on the the growth of these lactating cows, or in the milk productivity, or in the eggs, or the egg laying time advantage. All those things have been demonstrated, and I'm very happy to say that this technology is also being licensed to Mrs. Aquagri Delhi, and they will be basically soon marketing this product in next 6 months to a year timeline. And this product would now basically create a kind of a huge impact in the veterinary sector as well, the way that it has demonstrated in the plant sector. And as I said, I mean, all this research work in terms of intellectual property generation, because all these works are protected by the intellectual property, backed by a kind of a very high fundamental science that benefits both the society and the industry at large. And that's the reason, I mean, I'm very happy to say that 2020 institutional ranking, we are one of the top 10 institutions in the country, and we are one of the top 550 institutions out of 9,000 institutions evaluated, where the evaluation is done in terms of how the science is benefiting, how the intellectual property is benefiting both the society and industry. So with this end note, I just wanted to leave a message that collaboration is key, and science is no exception. And in fact, I believe in science, it is all the more necessity. So we always have to basically work on the quadrant, which are intersection of not you win or they win. It should be we win, should be the mantra that we should be taking it up in science for the larger gains of the, the humankind. With this, I mean, since I've been told that many students would be participating in it, I would encourage and welcome the students at different stages of their careers, or young researchers who wants to pursue kind of a high-end research on several of these domains that we have been working for a purpose. You're welcome to join this institute, and then together we basically create a kind of a new fortes of new discoveries in the years and decades to come. Thank you very much for your time, and I take this opportunity to thank the Gujarat Technological University, and in particular the Honorable Vice Chancellor and Amit for providing this opportunity to share some of our thoughts and some of our happenings on this forum. Thank you very much.
Thank you very much, sir, for sharing your wonderful knowledge. This is a very informative session. It's been a pleasure to have you, sir. Thank you so much, sir. Participants, anyone having any questions, they can drop their questions in chat box. Thank you, sir.